Today in this video I will show the result of my logistic regression experiment as we analyze how the shift distance affect the decision boundary and the model parameters. So for the shift start, I'm gonna use 0.25. For the shift fence, I'm gonna use 2.0, and I'm gonna make 8 different numbers of steps. When I run an experiment, so here's my result plots and another plots here. So as we increase shifts from 0.25 to 2.0, we can see there's two different classes are clustered together in this plot, but as the shift distance increases, there's like separating each other's. They're like moving farther each other's because we're shifting the class 1. So initially at like lower shifts distance, the decision boundary is relatively close to the like a cluster of data points, but as shift distance increased, the decision boundary moves like farther away from these two clusters. Like here, the cluster is like farther from the decision boundaries. So specifically, when the shift distance increased, the separation between two classes become more like pronouns. You can see it, and then we we basically calculate a better 0, better 1, better 2, and like slope and intercepts based on these two decision boundaries. So now let's take a look at the plotted parameters. So for the first plot here, we can see as shift distance increase, the beta 0 value decrease, but in contrast to that, like shift distance increased and then the beta 1 and beta 2, like the slope parameters, like increase at the same time. And when you look at the like a slope and intercept boundaries as is shift distance increasing, you can see maybe the slope is like decreases and coming back, and for the intercept ratio you can see like it like oscillate and then it coming back and then like kind of looks like staying in the similar area, maybe like converge. So probably like these two steps were like trying to find it better intercept ratio. And also when the shift distance like increases, we can see like logistic loss is like decreasing, and as long as the margin width. So when you look at the 8 different plots, when the shift distance is lower, then we can see the margin width is like bigger. That means it's kind of like not like efficient way to like classify, because like there's like a more possibility, basically like a broader possibility of like which classes in which places. But like as you see the shift distance increases, the margin width is decreasing, and then we can see like, oh, this part is class 0, but this plus is class 1. So in this conclusion, I show how logistic regression changes in like the data distribution changes as like distance. Thank you for watching.